Hello, today is lesson 6.6. We're solving radical equations. A radical equation is an equation with radicals that have variables in their radicand. An example of a radical equation is the cube root of 2x plus 7 equals 3. So basically what we're going to do is we're going to isolate the variable, raise each side of the equation to the same power to eliminate the radical, and then we're going to go ahead and solve from there. Now, of course, you always need to check to make sure there's no extraneous solutions. That means when we get the solutions, they work in the problem, because sometimes they don't. And you'll see what I'm talking about because we're going to go ahead and try some examples together. Okay, so I'm going to go ahead and solve one that looks like this. Now we want to isolate this radical. So what I'm going to do first is divide both sides by 2. When I do that, I have the cubed root of x minus 3 equals 2. Now, when we had a square root in the problem, remember we would square both sides. So now I have a cubed root, so I'm going to make sure I cube both sides. When I do that, I get x minus 3 on the left, and I get 8 on the right. Now go ahead and get x all by itself. I add 3 to both sides, and I get x equals 11. And when I do that, I'm just going to check my answer. If I do 11 minus 3, I get 8. The cubed root of 8 is 2, and 2 times 2 is 2. Usually you have to watch when there's a possibility of having a negative radical when it's even. And like I said, we'll try that. We'll see one like that in a little bit. Go ahead and pause the video and try this you try. Now, if you take a look at it, we already have the radical by itself, so you're going to start by cubing both sides. If an equation contains a power with a rational exponent, you can solve the equation using a procedure similar to the one for solving radical equations. In this case, you will first isolate the power and then raise each side of the equation to the reciprocal of it. Because remember, when we have a rational exponent, it is a radical, because we can turn this into, if I look at this problem, I could turn it into the cubed root of x minus 5 raised to the 4th power. So what you can do instead is, as long as this radical or this exponent's by itself, which it is because we can't pull one of these out of the parentheses, we're going to raise both sides to the opposite. Now, I'm raising both sides to the 3/4 power. So what I'm doing is I'm taking an even root. So if your denominator is even, what you have to make sure you do is a plus or a minus. Very, very important. We're going to take the 4th root of 81, and then we're going to cube that answer. On the left, I get x minus 5. So I'm going to stick with the x minus 5 on the left. I'm going to write my plus or minus. Now, the 4th root of 81 is 3, and then 3 cubed is 27. Okay, now I'm going to add 5 to both sides. Now be careful when you do this. You're going to do 5 plus 27, which is 32. And you're going to do 5 minus 27, which is negative 22. If I plug both of those back in, it will work, because when I plug it back into the original, I'm taking an odd root, so it's okay to have a negative. You can take the odd root of a negative, so both of these work. I'd like you to pause the video and try the you try, and just to give you a hint here, the first thing you're going to do is divide both sides by 3. Once you do that, then you're going to raise both sides to the 2/3 power. Okay, this is just talking about checking for extraneous solutions, which we've already been doing, but now we want to really be careful because we're going to have radicals on both sides. All right, when an equation contains 2 radicals, you may need to square each side twice in order to eliminate both radicals. Some of these problems can get very, very messy, and I'll show you when we go ahead and get started. Okay, now, number 1. This radical is all by itself. So what I'm going to do is I'm going to square both sides. Now be careful. When you square the left side, you have to FOIL. It's x plus 1 times x plus 1. You absolutely have to FOIL. Do not distribute that exponent. So when I do that, I get x squared plus 2x plus 1. And on the left side, the radical just disappears, so I get 7x plus 15. Now, I can see I'm going to have a quadratic equation because I have x squared and I have an x term, and it doesn't look like the x squared is going to disappear. So what I'm going to do is I'm going to get this equal to 0. So I'm going to subtract 7x on both sides, and then I'm going to subtract 15 on both sides. When I do that, I get x squared minus 5x minus 14 equals 0. Okay, this is a simple AC factoring problem. If you were not able to factor it, you would need to do the quadratic formula, but this one we just say what multiplies to give me negative 14 and adds to give me negative 5, and that would be negative 7 and positive 2. So I get x minus 7 and x plus 2. Then I set each parenthesis equal to 0, and I get 7 and negative 2. Now, check both of these solutions. Watch what happens. When I plug 7 in, I'm going to plug it into the original. It's going to work. I'm going to get 7 plus 1 on the left, which is 8. I get 7 times 7, which is 49. 49 plus 5 is 64. Square root of 64 is 8. Perfect. Works. Now, when I plug in negative 2, I get negative 2 plus 1 is negative 1. Right away, you can stop. There's no way even radical, a square root, can equal a negative number. So I know this one doesn't work. My answer is just x equals 7. Okay, now number 2 is about as messy as this problem can get. If I look at number 2, I need to square both sides, because if I move the 1 over, I still have 2 radicals. Nothing's really changing. Now, what you have to be careful of is when you square this side, you have to FOIL this. So what we're doing is the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. Okay, watch what happens. These two multiplied together is very simple. The root disappears, x plus 2. These two multiplied together is just root x plus 2. These two multiplied together is just root x plus 2. So I have root x plus 2 plus root x plus 2. What do you get when you add those? 2 root x plus 2. Then I multiply these two together and I just get 1. On the right side, my radical disappears, so I'm left with 3 minus x. Okay, this looks like a mess, but what we're going to end up doing is combining our like terms and getting this radical all by itself. So watch what happens. I get x plus 3 plus 2 root x plus 2 equals 3 minus x. This ends up working out quite nicely. I subtract 3 on both sides. That disappears. I subtract x on both sides. So I get 2 root x plus 2 equals negative 2x. Then we're going to go ahead and divide both sides by 2. So I get root x plus 2 equals negative x. Now to get rid of this radical, I square both sides. So I have x plus 2 on the left, and on the right, I have x squared. Okay, because negative x times negative x is x squared. I'm going to get it equal to 0. So I have x squared minus x minus 2 equals 0. What multiplies to give me negative 2 and adds to give me negative 1 would be x minus 2 and x plus 1. I know this is messy, so I have 2 answers. I have positive 2 and negative 1. Now this one, you would think when I plug in negative, it doesn't work, a negative 1. Actually, it does, because look, when I plug in a negative 1 over here, I have 3 minus a negative 1, that becomes plus. This one, I have negative 1 plus 2, that becomes a positive. This works. What doesn't work is 2. Okay, watch what happens when I plug 2 in. 3 minus 2 is 1, square root of 1, or square root of 1 is 1. Here, I have 2 plus 2 is 4. Square root of 4 is 2. 2 plus 1 is 3. They do not equal each other. So my answer in this problem is just negative 1. I know that seems messy, and that is as messy as this problem is going to get. It's not so bad if you look at number 1, and it's not so bad if you look at the U try. Your U try, this is perfect, because if I square both sides, look what ends up canceling. Root cancels, root cancels. You just have 2x plus 5 equals x plus 7. Go ahead and solve that one. And the last thing I want to show you is, and this will come up on the ACT, is solving for a certain variable. So this is a word problem. The velocity of a free-falling object is given by v equals the square root of 2gh, where v is the velocity in feet per second, g is the acceleration due to gravity in feet per second squared, and h is the distance in feet the object has fallen. On Earth, g is 32 feet per second squared. If the velocity of an object when it hits the ground is 104 feet per second, find the distance from which it was dropped. So what we're looking for in this problem is our h. So if we write our equation down that you're given, we're going to plug everything we know that we know and find what we don't know. So the velocity is 104, the g is 32, and the h is what we're going to find. Now, first thing I would do is I just go ahead and square both sides, get rid of it. So I get 104 squared is going to be a pretty big number. It's going to be 108/16. And then I get 2 times 32, which is 64h. And then all you're going to do is divide both sides by 64. So this one's not so bad. We get the height to be 169 feet. Okay, any questions, comments, or concerns, go ahead right at the bottom of the video, and I'll see you tomorrow in class.